the general overview of the caches. So let us focus to the cache memory now. So this cache memory, it consists of cache line. So in the cache line, each cache line is made up of frames. So frames having three fields. One, the tag field. Second, the state bit field. Third, and data field. Where data field in the cache line used to hold a copy of a block of data from main memory. And once the valid block of data is fetched and loaded into the cache line, the valid status bit is adjusted. Then from the block address, the cache line address is computed. That is tag address. The cache line address is computed. That is the tag address. So in the tag field, the cache line addresses are updated. Whereas in the slot column, you'll find slot 0, 1, 2, 3. That means cache line 0, cache line 1, cache line 2, cache line 3. And this cache line is made up of frames. Right? So these are the overview of the cache line to understand the cache line. Next, to address the three policies which we have mentioned in our previous slide. That is, how do we find whether the cache is inside the cache memory or not? So there, the cache line matching algorithm is used. So in the cache line matching algorithm, cache line is identified with its address, that is the tag addresses. Tag addresses computed from the block addresses, the block memory addresses. So that is to identify the policy that the identification policy, cache line identification policy. When CPU send a request for a particular cache line, for a piece of data that is in that cache line, let us assume tag 1. That means cache line 1 address it is. That means searching in the cache memory by a particular cache line, whether it's having data or not. So how it works means if the incoming tag is, so assume that in the cache memory, some tags are already stored here. That means the cache lines are there inside the cache memory. So if the incoming tag is equal to the stored tag, so then there is a cache hit. So like for the first 4 cache line addresses like tag 1, tag 2, tag 3, and tag 4, when these requests send in a sequence, then they compared with the tag 1, tag 2, tag 3, tag 4. So incoming tag is matching with the stored tag, so there is a cache hit. If CPU is sending a request that tag 5 that compares with the stored tag 1, 2, 3, and 4, it is not matching with any of the tags, then we say that the algorithm says incoming tag is not matched with the stored tag, so there is a cache miss. So when there is a cache miss, then needs to address the cache replacement policy here. Which existing cache line should be replaced for tag 5? That means it must evict a cache line which is currently in the frame. So that read requested data from memory or high level of the caches. Then replace with cache line read from memory or high level of the caches. Then return the appropriate word within the cache line. So this is the main issue, the overview of this design one. So for this, let us see for the cache placement policy. So we'll discuss one by one.